Hello and welcome to a new problem solving session. We are still talking about the electric dipoles, and here is a problem that says find the magnitude of the dipole moment P of a thin rod of length L, the linear charge density of which depends on the distance x to one of its ends. And that is given. Lambda x is given as you can see in the statement, and a is a positive constant. So here is the basic concept involved in solving such kind of problems. The electric dipole moment of a neutral discrete system of charges, that means in which the total charge is equal to 0, is given by, theoretically it is given by dipole moment P is equal to summation of Qi Ri vectors, where Ri is the radius vector or the position vector of the charge Qi relative to an arbitrary reference frame, and the summation is carried out over all point charges Qi included in the system. And this is the basic principle, with the condition that the net charge, that means you have to assure first that the system is neutral, and in various cases, like in case of linearly distributed charge, suppose charge distribution is lambda, and then you need to assure first that lambda dl, charge per unit length, is dq by dl. So we can write here over the whole length it must be equal to 0, and then you calculate its dipole moment simply by calculating this integration, that is lambda r vector r dl. And in case of surface distribution of charges, you need to assure that your sigma r ds must be equal to 0, that is net charge is equal to 0 for the entire surface, and then you calculate dipole moment simply by sigma r ds. Qr is q multiplied by length is simply the electric dipole moment, and in case of volume charge distribution, you need to ensure first that rho r dV, that must be equal to 0 over the whole volume, and then you can calculate dipole moment simply by writing rho r dV for the whole volume. And that's the procedure to find out electric dipole moments. Now, how can we do this? How can we solve this problem, this particular problem? I'm going to show you pretty soon how we can solve such kinds of problems. And so let's read the statement of the problem again, and try to find out how can we do this. And you can read the statement of the problem again, that is at your screen, and well. So you must have read this again, and now we are going to solve it. Suppose that x-axis, this is the rod, and I have set up an x-axis along the rod, simply like this. And let us first check that whether the system is electrically neutral or not. So to do this, we are going to find this integration that simply says total charge on the rod, and to find the total charge of the rod, we need to set up the integration from 0 to L, because origin of the x-axis is at one of its ends, and we can write here the charge distribution, that is 0 to L, and charge distribution was simply 3x square minus L square lambda x. You can see it here again. Oh, A is missing, so no, I have already written A here, and if we integrate this, we will get, it will come out equal to 0. So now we are going to simply find out the dipole moment of such a system, and in a scalar form it can be simply written as 0 to L lambda x x dx, and by putting all those things together we can calculate this integration as well, x dx, and I guess it will come out like this 0 to L, and your result you will finally get is A L raised to 4 divided by 4, and that should be the answer, and the problem is being solved. Thank you very much. I'm going to provide one more problem of this kind, not more than that, and thank you very much for watching.